So next up we've got Devon Coppin. He's from DECA.
DECA Process Control Solutions.
Yeah, so he's sort of been working a little bit with Peter Ivers and a few other people within the region, and it's just sort of another company, I guess, that are doing this sort of water monitoring and measurements. So just a bit of an interesting one. So you could hear a few things about what Devon's been doing in the region.
Yeah, morning. Morning all. Thanks for attending the presentation for today. As Kieran said, my name's Devon Coppin. We're just a small business partnership between me and my wife. We first started out 8 years ago, just doing a little bit of work around my brother-in-law's and sister's property, wiring a station down near Kainoona there. Just setting up, first of all, there was just surveillance systems on turkeys' nests, eventuated to pump control, so everything's all done from the homestead, and all information can be relayed back to the homestead. Well, we come from Townsville, live in Townsville. We've got a small sort of clientele in Townsville itself, deal with food manufacturing companies, sugarcane, irrigation systems, pump controls, VF drives, speed controls on pumps, governing flow control, governing pillar height control. Also do a fair bit of design work and drafting for various small companies within Townsville, all around process control and automation systems. What we do, we provide automation control solutions ranging from single point of measurement to integrated automation control systems. So factory, food manufacturing businesses, conveyor systems, all that information to relay back to the SCADA system for an operational interface. PLC programming, SCADA systems, which is the backbone of the whole control systems. Data networking, radio telemetry for remote systems, instrumentation, virtually anything that's out there. You know, we're looking at turbidity there before. We can actually use an instrument to actually measure that on a continuous basis. Oxygen levels, anything that you can think of, there's always an instrument out there that actually will do that measurement for you. CCTV surveillance systems. Again, some of it's on properties themselves, just looking at turkeys' nests, relaying it all back to the actual homestead itself. Have done some systems with companies in Winton, butcher shop. They actually have the slaughter yards out of town. So rather than having a third party Telstra relaying that information back through the Telstra system back over to the main butcher shop, costing data, it would have added up quite substantially at the end of the day. So what we ended up doing there was we set up a wireless network, and we brought all that information back through a wireless network straight back to the butcher shop itself. So some of those cameras are used in the slaughter yard for government, where they're required to record footage of, for humane reasons, I suppose, for killing of animals and stuff like that. So that's all recorded back at the butcher shop. They can go back and call up all that information at any time. Drafting, so mainly around electrical automation systems in the area. So as Kieran said, Peter contacted me looking at doing some flow measurements on his property. Rose Downs is probably a little bit unique where it's got a positive head bore and also capabilities of one flow meter, doing all the measurements right down through the property's 8 kilometre long lines.
I think 16. I'll give you a short rundown, Rosalie, because originally never thought that was going to happen. So one of the gaps is...
Peter, can you just stand up there close to that Devon so people can hear you, please?
So one of the gaps is getting when we replace the suitable get.
Thank you.
So when we replaced the board drains, I wanted a system. I was worried about the safety aspect, use of board drains and running into holes and that type of thing. So, and also part of that system obviously involved an effective monitoring system which would detect faults early before I basically perish capital troughs. So it's a client-based system now, and so I just need to be, cost-effective and comply with their funding arrangements. It needs a sign-off from a registered practicing engineer. That's for them to accept the system you put forward to them. So the system I settled on at Rose Downs was it's all on 2 pipelines. It's about 35k pipe in total. It's a share bore, so there's actually 10k of that pipe's taken up getting into Rose Downs. They're all direct fill troughs, and I limited the flow into the trough, so the first trough on the line, or the second trough, or third trough fail that doesn't rob all the water out of the subsequent troughs. And as part of that system, it's just on a water monitor. Relays all the same information, back to the homestead. So you've got real-time cattle consumptions. Kieran's been out there and had a look over it. We've put a stick in it to get all the data on it because they're interested in looking at, the correlation between temperatures, time of year and whatever with water consumption. It's only just now that the water surface, the surface water's dried up, so we'll, the data we'll currently get will be full consumption of what they actually consume. So with leak detection, it's on an alarm. So every 24-hour period, there's a period within that 24 hours where cattle don't consume water, normally between the hours of 2 to 5, most probably. So if there's a leak in the system, anything's leaking, you've got a flow there, and you can set the amount, and there's an audible alarm when you walk out in the morning. We're currently working to have that upgraded with, because the Telstra modem I had wasn't that effective. So Devon, is currently working on that modem, so I'll be able to have remote access, hopefully and a remote alarm system. I've got confidence in the measurement part of the system, and we're also going to put a maximum flow level on it, which should alert me to, and once again an audible alarm, which should alert me within an hour if that system is malfunctioning. So it's all around, the safety of the system. The data is all free. It measures in litres a minute. When I first designed the system, it was in the back of my mind to have an effective monitoring system. I looked around at what was available on the market, couldn't see exactly what I wanted in generic form. My son, who was actually a mechanical engineer and had worked with Devon at the sugar mill, put me on to Devon because he said he was mucking around as a sideline, and that's how this system was developed in conjunction with Devon to what I wanted. It's had about 8 months now of in operation, and I believe it's 100% accurate, and I'm more than happy with the results. The other thing is I've only used 75mm pipe and 60mm pipe, as I said, 10 kilometres to get the water into me, and the system will actually handle 4 times the recommended stocking rate. And so that's where our tanks and direct feeding troughs, and there's no more, except there's been two sort of triangular corners, there's no more than 2 kilometres to water. You know, spread the grazing out very, very effectively. Cost-wise, most probably cheaper than tanks, just substituted more troughs by less central tanks. Yeah. So I'm not saying it's applicable to every system. Obviously, you need positive head board, you need to work certain things out, but there's nothing that's too out of the normal available material that people currently use to generate water. So that's the background to that. So that's, you know, Ben was about to show you. And some of the information, I'm obviously, you know, Kieran and I said they can have free access, they can comment on it, they can say whether they think it works or not. So we've got given Kieran, you know, direct access to all the information. It reads in litres per minute. So he's got that much data. He's had trouble with his, you know, worksheets of collating back the information that's more applicable to, you know, what you would want to look at essentially. Yeah, so yeah, that's just the background to us. So I'll let Devon continue on with, and that's the practical aspect of the technology stuff I don't really understand, but I do know it works, and I'm very happy with the outcome so far.
Thanks, Peter. So again, it's I specialise in receiving customers. They come to me with their ideas, and then I create the system to suit their ideas. One of the other questions I ask pretty quickly is, how accurate do you want the data? Accuracy does determine cost. With Peter's system, he wanted it accurate, so there's a little bit extra cost in buying the actual MagFlow systems themselves, MagFlow instrument. So that particular MagFlow there is 0.01% of error in flow rate, so it's extremely accurate. So the system's based on a wireless network that's based at the homestead itself. At the homestead itself, it's got a little touch screen with a PLC in the background. So the PLC is doing all of your data acquisition, so there's a little bit of programming involved to get the information that the client requires. From there, it just goes out through what they call a nano station, ubiquity gear. This particular one shoots out 5 kilometres, goes across to a remote device that receives the 4 to 20 signal coming from the flow meter, and that information is just transferred back to the PLC. PLC transforms it from a raw count into a engineering value, so litres per minute in this case. So that's the basic system there. So there's a few photos of when we're actually setting the system up, a little bit of detail of information that was coming through. Kieran, do you want to talk about the data there itself?
Yeah, so we just basically this system, it plugs it into a few Excel sheets. So it's just a matter of collating all that. We had it, just how it was formatting was probably not quite right for what we need, but we're working on getting that changed. But pretty well, there's a point in time where Peter sold around 240 odd heifers, I think it was. So basically we just compared the intakes before they were sold to the intakes after they were sold. Pretty well just to have a look or how much of that total intake of the whole mob was of those heifers. So if you look at that graph sort of in the far top left there, the grey line in the middle, that's sort of the whole flow rate. So the total amount of water that's gone through each day. So we date down the bottom. So you see how that graph with the grey line is steadily increasing. That's sort of thought to be that there's still a little bit of surface water around, and then that was drying up. And then as that dried up, sort of they were all sort of coming onto the troughs, so we got a bit more of our intake. And and then you sort of see that, so the top sort of orange line, that's basically our max daily temp, and the blue one's our minimum daily temp. So once that sort of surface water dried up, we sort of get a pretty good relationship between how the intakes are actually tracking that temperature. And I was actually quite excited to see it, and saying this was just after they were sold. There's a very strong relationship with that maximum temperature at that time of year, how much water those cattle are actually drinking. So it tracked pretty good. And then this graph down the bottom, so the blue bars there, so this is just basically midnight to the following midnight there. So it just shows how much water they were drinking at what hour of the day. So the blue lines are before heifers were sold, and then the orange ones is after the heifers were sold. So it's essentially just showing that there's less water being drunk after they were sold. You've got 240 less head. But we did notice a similar trend to what we saw at the trial paddock with the farm lot sort of, if you look at the actual tank level and how that's going up and down. So the animals, at this time of year, they're coming in around sort of 7 or 8 o'clock, peak consumption around 8 or 9 o'clock. They're going back out, coming back in potentially for a later drink, sort of 3 or 4 o'clock in the afternoon, and they'll go back out. It's also surprising just to seeing little intakes over the night. A lot of people sort of, I guess, think cattle just sleep at night and don't do anything, but yeah, they're obviously still drinking water at night, which is pretty cool to see as well. But yeah, we're just going to do this same sort of thing and just follow how their intakes change with temperature. So that's pretty cool.
Do you think that those afternoon intakes were the same cattle as the morning intakes by the litres that were drunk?
The same cattle, you reckon?
Do you think it was the same cattle because of the same amount of intake at the afternoon session as the morning session, or was the intake in the afternoon session less? I don't know. That's
a bit hard to say.
Can I just comment on that? Like, I looked at a lot of data before I installed this system, and contrary to popular belief, the only data you can really hang your hat on is feedlot data. And grazing data, to me, monitors what feedlot cattle do. So cattle in general do not consume any more than 6 litres an hour. That's the maximum consumption you're looking at. So in answer to your question, yes, it's the same cattle throughout the day. Physiologically, when you think about it, I think it's impossible for any animal. Because if you perish cattle and you let them, you go to spot the water, you kill them. Their system's not designed to be able to store water for days in activity. So I think the answer to that question was critical. And I had to establish that because DNRM, who administered the Gadsden scheme, didn't. They had guidelines, and my guidelines didn't fit in with their trough times. But the benefit I had was that the engineers who were driven by data were required to sign off on the program. So that was the end of that argument. They didn't particularly like it, but as I said, I'm super confident that I've got 4 times the capacity in my system that is required to manage to water the standard stocking rate. So, and if you look at even yesterday's data, peak consumption as per that graph was, and I know it's got the many cattle on the place obviously, was around that 8 o'clock period, and peak consumption there was just on the year 4 litres for that hour. So cattle, I just think that the notion of cattle come in and drink 40 litres in one go is, and eventually this data, I'm hoping will show that, because there is that general perception out there that that's what cattle do. I don't think that's what cattle do. And I think that eventually will prove, I think it's what's proved in my mind already, that eventually I think there might be a bit more data that will show that.
Yeah, so there's certainly the megabytes of data coming from the system. So we'll try and tone it down a little bit for you, see how we go. So just once again, look, DECA just specialises on just working with the client, getting the information from them, what they actually want, and then we'll just tailor-make the system to suit the client using various pieces of equipment to bring it back to an automation system. Where we all started, wiring the station, 8 years ago. My brother-in-law started to ask questions whether we can start monitoring bits and pieces on his station. So we started installing at that time just surveillance cameras, looking at turkey's nest levels and other bits and pieces. Eventually, we automated the pump control, so it would actually automatically stop his pump, and he had full control from the homestead to do that. So instead of driving down to the pump station, he could actually just stop it at the homestead when he wanted, or he just put it into auto and just let the system run from there. So generally that's how sort of Warrima sits at this stage. So back through the internet, again with the new modems on the market these days, Telstra have very much locked them down. So port forwarding and stuff like that for remote access is got a little bit harder. So I'm just going through a process now to try and find a piece of equipment that will give us that interaction back again. Touchscreen, PLC based. It's based on a network that can transmit out to 50 k's if need be. It can go further for a repeater station if you wish, but again, that's extra cost to get that system up and running. 15 k's maximum is the lower end, and looking Downs country suits the system quite well. It's all line of sight, no trees, no hills. It works really well. So Turkey's Nest with cameras on board, some valve control there, switching from various nests, pump control within the system itself. So Warrima Station, so there's a couple of little sites there. So this is his pump site, dishes pointing back to the homestead, Illaroo, Turkey's Nest. It's actually got a camera and a level control system. You can see the little float switches in the back there. Plain, simple float switches, no real intense sort of level indicators around there. So they're just a little bit of information that he sees back at the homestead, so he can actually look at his pump current, look at past trends over the last 7 days, Illaroo, Turkey's Nest, level control. And the other thing that he had issues with is loss of power out there. He's got a pretty old generator, so his generator seems to move speed with moving the frequency, so he's got to be on that all the time. So we actually monitor the power for him. So instead of pulling out his multimeter to go and check it, all the information's on the screen for him, so he can increase the speed or do whatever he needs to do, increase the voltage, decrease the voltage, to maintain a reasonable level of power within the system. So once again, it's tailor-made to what they actually want to see within the system itself. The surveillance system, we've got little sites where it's just a standalone camera. So that camera on the far left there, it will only operate during the day while we've got sunlight. During the night it actually shuts down. The reason for that is the cost of the solar cell system itself. With shutting it down during the night, you only need a very small battery and a very small solar cell to maintain it during the day. So that's probably more of a cost-effective way of using a surveillance system. So you can see just another little float switch set up there for his automation. it goes back through into an NVR. He doesn't do any recording or anything like that because there's really no need, but the NVR is capable of motion control, so if something moves, it will start recording, and you can access all that information back through the internet if you can. Once again, the NBN system that has been brought out has virtually shut all that down at this stage, so it's something that I need to get back into and start sorting out so we can get remote access back again. Just a few little things that we've been playing with lately. So early detection on tank level alarms. Normal tank, they'll have a float switch in there. Once it gets down to a certain level, it'll bring up a low alarm. But what we're actually doing is we're monitoring the level through a analog device. From that analog device, we can actually calculate flow rates, inflows, outflows, using the PLC to do those calculations for us. So we've developed a little bit of a system where you'll have your normal droppage due to usage within the cattle troughs and everything there. So we developed a little bit of software that looks at the slope, so the deteriorating change of level, and if that change becomes too great within a certain period of time, it will flag it as a excess flow, indicating that he's got a leak somewhere. So we're hoping that that system will save a considerable amount of water. Just on that simulation there, you'll be saving somewhere around the 40 kilolitres of water. His tanks, a couple of his tanks are 200 kilolitres, and if he loses a tank due to cattle popping pipes off, it takes him a week to recover because most of his property is gravity fed. So it is a bit of an issue for him. So we're hoping to get that up and running as soon as we can. Once again, all the calculations will be done with PLC. An interesting one that we just found out last week, he installed a new pump. He's gone from 1.1 litres per second to a 2.2 litre per second within his bore. We were a little bit worried about the bore dropping with this extra flow rate, so we decided to install a level transmitter within the bore itself. The data that we got back, we sort of scratched our heads for a little while. We noted that when we started the pump, instantaneous, yes, the water level drops down, which is probably right. But after a period of time, we noticed that the bore head actually raised a metre within the column. Me and Peter had a bit of a discussion about it. It could be from the stratification of temperature within the water itself. Could be the water being pushed up the column, pushing the water up in the system. So it was just something that we saw, and it was quite interesting when we got the raw data back. So the latest system that we installed was Tarbrax station. Tarbrax station was a little bit different to Rose Downs, where the homestead is actually fed off the deposit-fed bore. So what we had to do there to get back to our cattle flow rates was install a second flow meter back at the homestead to monitor the actual flow going to the homestead. So basically, PLC, once again, was just used to do calculation. Bore flow minus the homestead flow equals cattle flow. The distance between the two flow meters is roughly 5 k's. And I was a little bit concerned about the lag within the system. But when we got it going, we actually got some data from the system The lag was less than a minute between the homestead bore, so someone turned on the tap or flushed the toilet, it'd be less than a minute to actually see the data coming through on the bore head itself. So it's quite quick to pick up the system. So once again, just its own network set up on the property. The base station back at the homestead goes out, collects the information from the homestead flow meter, and also collects information from the bore head, which is roughly 5 k's away. So the system also looks after itself. It monitors battery voltages, so there's alarms on battery voltages and stuff like that. Once again, there is alarms for leak detection. I hope to improve on those instead of a 24-hour period. We'll step it up and see if we can actually get some alarming within an hour if there's issues within the system itself. So this is just a little bit of data that come from Tarbrax, sort of over a 7-day period. The top graph there, so you can see your bore flow is the blue, your homestead flow is the orangey colour, and then the cattle flow is the grey colour. It's interesting to see in the middle there's some very large spikes. Some of those spikes were due to a council truck coming and filling up at the bore itself. And what I ended up working out was these mag flows are capable of reading forward flow and reverse flow. And what I think it was is when the pressure was released on the 4-inch line to fill the truck, the pressure in the poly pipe system backfed and fed back into the truck also. So just this pressure drop caused a backflow back towards the bore, which gave us those instantaneous spikes there. So Tarbrax is also a little bit different. They have troughs, so tanks, sorry. So you can actually see where the tanks are filling, which is a little bit different to the sort of data that Peter sees with the positive pressure system that he's got there. Basically it. Thank you.